In this video, we're going to go over your Unit 2 end of unit retake test, just to go over some of the skills that this test is evaluating and give you a little bit of extra help on making sure that you can do the assignment. The first question is just testing how well you are able to use ratio language in order to write ratio sentences. A ratio is just a comparison between two or more objects. In the scenario on the screen, we are comparing the amount of pink circles to the amount of black circles and the amount of blue circles. When we write a ratio sentence, we use ratio language. Ratio languages includes words like the ratio of is and for every there are or there is. Now you do have sentence stems for letter A and B that you are filling out, and then for letter C you are writing your own sentence. So when we're trying to fill out the first one, what we want to look at is what number or what category comes first. So in the sentence on the screen, it says the ratio of pink to blue is. Since the word pink comes first in my sentence, I need to take the number of pink circles and put it first in my ratio. There are 4 pink circles. So the ratio of pink is going to start with the number 4 because that is the number of pink circles. To blue, since there is only one blue circle, we're going to put a 1. And when I go to write my ratio, I just use a colon between those numbers. So the ratio of pink to blue is 4 to 1. That is the comparison of how many pink circles there are versus how many blue. When I go to fill out the next sentence stem, it's similar for every blank blue. So since the word blue comes first in my sentence, I need to use the number of blue circles in this blank. For every 1 blue, there is or there are 2 black. For every 1 blue, there are 2 black, because that is the number of black circles in my diagram. And then if I were to write my own ratio sentence using the word for every, I would just start it off for every blank. You can pick any category you want. For every 2 black, there is 1 blue. For every 2 black, there are 4 pink. However you want to phrase that, you are just writing a sentence that allows you to compare one of the colors in our diagram or one of the shapes in our diagram to another shape. The next question is all about equivalent ratios. So we need to think of what makes a ratio equivalent. Let's say that I gave you the ratio of 20 to 15, and we want to look for ratios that are equivalent to that. Equivalent ratios are made by taking both numbers in my original ratio and either multiplying them or dividing them by the same number. So for example, when I examine the numbers 20 and 15, both of these numbers are divisible by 5. If I divide both 20 and 15 by 5, I end up with an equivalent ratio of 4 to 3. I could take 4 to 3 and make another equivalent ratio by multiplying both these numbers by something else. So let's say that we multiply them both by 7, for example. 4 times 7 is 28, and 3 times 7 is 21. All 3 of these ratios are equivalent to each other. Now, 28 to 21 doesn't look like it's equivalent to 20 to 15 automatically. In order to realize that the top ratio and the bottom ratio are equivalent, you kind of have to drop down and make the middle ratio. So as you're looking at the options on question 2 for which ratios are equivalent, you shouldn't just consider the number 12 and 8. You should consider what smaller batches I can make out of 12 and 8 if I divide them, and if that smaller batch can be used to get one of the other ratios in your list. They're not always intuitive, which is why you should actually be showing your work in order to prove which ones are equivalent to each other. Without this step of actually figuring out what you're multiplying or dividing by, it's very easy to miss ratios that should be marked as equivalent. And then for letter B, you're writing your own equivalent ratio. So you're going to take the number 12 and the number 8, and you're going to just pick any number to multiply or divide them by. So let's say that we just want to multiply them both by 100. You could do that. That would make an equivalent ratio. Or if you want to multiply them both by 2 or 5 or any other number that you can think of. So you need to look at all of the options that are listed. You need to think about how you could use the 12 and the 8 to get there. And again, you might have to go to a smaller batch in order to get some of the other numbers. So you need to actually consider every single ratio and how they might relate to each other when you're selecting equivalent. Because if 28 and 21 is equivalent to 4 to 3, it's also equivalent to 20 to 15. So you definitely need to show some work for this question. Question 3 is what we call a part to whole ratio question. We're going to do a similar one for our review. So let's read the question. It says there are 12 red marbles for every black. If there are 130 marbles, how many are black? So anytime we have a ratio question, we want to make either a ratio table or a double number line. I'm going to make a table because I think that the strategy for a table is a little bit quicker because we don't have to skip count. So in order to make a table, I need to look at what my categories are. My categories are red, black, and marbles. So if I have 3 categories, then I need 3 columns in my table. I need to make sure that they are labeled. So we're going to put red here, black here, and marbles here. Next, I need to fill in my numbers for the batch that they gave me. I know that there are 12 red marbles for every black. Now, the phrase for every means 1. We've talked about that quite a bit when we talk about a rate per. Per, for every, unit, all those numbers mean 1. So there's 1 black marble. If I have 12 red marbles and 1 black, I don't have 130 marbles in my bag right here. So that 130 represents the larger batch that we are trying to get to. It doesn't represent how many marbles are in one batch. So I'm going to put that number down here as the number that I'm trying to end up at. In one batch of this relationship, there are a total of 13 marbles. This is a part to whole ratio, and the way that we get our whole is by adding our 2 parts. So part plus part equals whole. You should have that written in your journal from when we did this lesson. Now I'm trying to think about the math involved in getting from 13 to 130. 13 times 10 gets me 130, which means in order to answer the question, I am doing times 10 to every number in my row. So 12 times 10 is 120, 1 times 10 is 10, and that makes sense because 120 plus 10 equals 130. So you can always check your answer by making sure they add up to be the same thing. Now my question was, how many are black? So my answer would just be 10. Your final question is asking you to write a sentence in order to compare 2 different ratios. We have talked extensively in class about how to compare ratios. We should know that in order to compare ratios, we have to look at when one of the categories is the same number. So right now, as is, I'm not able to compare a reading rate of somebody who read for 2 hours versus somebody who read for 3. Because these are different numbers, I'm not able to use what I have in order to tell who's reading faster. Instead, I need to make equivalent ratios so that at least one of my categories, either the pages or the hours, is the same number. Now, we can either look at a number that 50 and 150 have in common, or we can look at a number that 2 and 3 have in common. Usually, we tend to pick the smaller or the easier numbers to work with, so let's just think about 2 and 3. I need a number that I can skip count by both in order to get the same number. So if I skip count by 2, and I skip count by 3, they both have a 6 in common, which means that is the number that I can use. So if I figure out how many pages each person read in 6 hours, I can compare them. In order to do this, I'm going to make a ratio table. So my categories for my ratio table are pages and hours. I'm going to make a different ratio table for each person. Now on your test or your retest that you're taking, it just asks you to fill in different rates for each person. So you need to make sure that you fill in every single row that it gave you. For our purposes, I'm just going to fill in enough rows to answer the last question. but on your paper, I want equivalent ratios in every single row. Now, in order to answer the last question, to write a sentence comparing them, again, we can't have a 2 versus a 3. We need to turn them into a number that they'll have in common. So I can turn both of these numbers into an equivalent ratio using a 6. So in order to do my table, I need to think about how many times I'm skip counting by a 2 to get a 6. That is 3 times. If I'm skip counting 3 times by my hours, I also have to skip count 3 times by my pages. Now, if you need to actually make a number line and come over here and skip count in order to do that, you can, or you can just use multiplication as well, because multiplication and skip counting are the same thing. Either way, Maya can read 150 pages in 6 hours. If we do the same thing for Tom, we're trying to get from a 3 to a 6. From a 3 to a 6 is times 2. So if I double both of the numbers in Tom's ratio, I find that he can read 300 pages in 6 hours. Now that I'm looking at the same amount of hours, I can compare how many pages they read to tell which person is reading at a faster rate. Tom is able to read more pages in the same amount of time, which means that Tom has a faster reading rate. So the sentence that I would write would be something along the lines of, Tom is reading faster than Maya because when he reads for 6 hours, he reads 300 pages. When she reads for 6 hours, she only reads 150. But you need to make sure that you use your ratio table to compare them and then write a sentence stating which person reads faster.